video, identifying domain and range from a graph, we're going to use the skills that we acquired in the first video on how to use interval notation to identify the domain and range. So the figure below again illustrates how the graph of a function is used to determine the function's domain and its range. And we're not necessarily just focused on functions, we're going to also look at relations and also identify the respective domain and range. Now, as you see right here, the domain of the function is going to be all of the x values where the function is going to exist. So the strategy here is to look on the graph and move to the very far left and find, again, the endpoint that's on the far left. That is going to be indicated, again, drawing a vertical line downwards to some value, which we will call x1 right here in our notes. So x1. Now our our domain continues then by then identifying, going back on our graph and finding a point to the farthest left. So sticking on my graph, I'm going to go to the very farthest right until I get to my endpoint, which is right here, and drawing a vertical line to the x-axis. We get to a point that we're going to call x2. So the domain of this function will be all of the x values that can be found between x1 to x2. And the strategy to finding the range, we just simply do the same thing but going up and down. So we move along the graph and find the lowest point on the graph, which would be this one right here. This happens to be the lowest point on the graph. And we'll call that y1. Draw a line to the y-axis and see what the y value is. Here we'll call that y1. And then moving up the graph until I find the highest point on the graph up here, we're going to draw a horizontal line to the y-axis. And we'll call that one y2. So the range here would be all of the y values that are between y1 to y2. Now, to express our domain and range using interval notation, we just simply again follow the strategy and the technique and the proper format for intervals. So since our lowest value on our domain is the one on the left, x1, the highest value is x2, we would write it again in that order, separated by a comma. Now, depending on whether we're going to include the endpoint, we'll determine again which one of these we're going to use, what type of brackets or parentheses we're going to use, and where we're going to use them in those situations. In this example, we're assuming because of the closed circles that we're going to again include them, so we would have to use brackets on the two endpoints to indicate that we're including them there. And now for the range, same situation. The range again is going to be all of the y values between the y1 and the y2. And since there are also again closed circles in those locations, we're going to use again brackets to indicate that we're going to include them. And again, the order of the y values are in the same, smallest to largest. Now, the set builder notation simply requires us to just translate these, just like we did on the first lesson, into that notation. Okay, so just acquiring the same skills and applying those skills from the previous video and the previous lesson to just translate these into the appropriate interval notation. And remember, the appropriate parentheses and brackets is dependent on whether we have open or closed circles on our pictures. And when you're doing this, there's two problems that you have to write in set builder notation, and you're only required to write it again in this format, and I'll show you again the proper way in the examples that we do. So let's turn the page and let's look at the examples that we have on the next page. On this first example that we have right here is we want to identify the domain. Let's start with the domain by, let me do it in a different color. Let's do it in black. The domain by first tracing over the graph and finding the point that is farthest to the left side. And that would be this point right there. That point there is farthest to the left side, and it just so happens to be on the x-axis of x equals negative 3. If it wasn't, I would just draw a vertical line to the x-axis and indicate what that value is. So we see here that, I'm going to do the domain in blue, that this vertical line indicates the boundary point for the domain. We're not going to have any point further to the left of that value. Now we're going to do the same thing now on the other end. We're going to look for a point that's farthest to the right, and that would be this point right there, drawing it to the x-axis, that is at x equals to 1. So there's not going to be any point to the right of this value here. Along the x-axis, this graph only exists no further than 1 and no less than -3. So in interval notation, the domain would be from -3 to +1. Now at -3, let me erase this here so we could see it. We clearly see that there's an open circle there, so that requires us to use a parentheses on that endpoint. And on the other end is a closed circle, so that requires us to use a bracket. Let's now translate this and write this using set builder notation. So because it's domain, it's going to be x, and our inequalities are going to be in this order. The point on the left is -3, so we'll put -3 here. The point on the right is +1, and we'll put 1 right there. So start by first writing in this part right there, because that's never going to change. And then just simply using your domain, your interval notation, indicate what the smallest number is and what the largest number is going to be. And then look at the endpoints, okay? Since this is open, this does not require an equal sign underneath that inequality. But since this one is closed, the bracket, that does require a equal sign underneath the inequality, okay? Now, on the assignment for today, you'll be required to either write it like this or like this. So be very careful and just be aware of how you write each one of them. Let's now move on to the range. Now, to determine what the range is, we're simply now going to move up and down the y-axis. So we're going to find the lowest y value on the graph. So if I trace around the graph, I see that this point is lower, and so is this one. So there's 2 possible points I could use, but I can see overall that this point and this point are the lowest points on the graph. So there's not going to be any point lower than this red line. So let me indicate that by drawing a horizontal red line with arrows pointing up. Well, it just so happens that this red line crosses the y-axis at -4 right there. So that is the smallest y value. -4 is the smallest y value. Well, what's going to be the highest y value? Well, moving again up and down, I'm looking for the highest y value, which happens to be either, again, this point right there or this open circle right there, but it's not going to be any higher than this horizontal line. So the strategy to figuring out what the range is to draw a horizontal line where the lowest point is and the highest point. And since this is exactly on the x-axis, that is where y is equal to 0. We do not go higher than that. So the range for this thing will go from -4 to 0, and we would have a closed circle on -4 because we see it here and right there, and we would have also a closed circle on 0 because even though it's not included here, it is included right there, okay? This has a closed circle there, so we can have a y value that will equal to 0. Now, to translate this into interval notation, let me move this downwards. Let me move it over here. In interval notation, we're simply going to write y in the middle, less than and less than on both sides. And using the interval, our lowest value is -4, our highest value is 0. And then just put equal signs on both of them because it's closed on both ends. We're including both endpoints. Let's now look at the second example, and let's identify the domain first. So again, the strategy is to look at where the graph is going to move farthest to the left. So simply grab any point on the graph, okay, and move to the left. Moving to the left in this situation is also moving downwards, and it'll look like, according to this right here, we would stop right there. The arrows, however, indicate that the graph is going to continue moving down and continue moving to the left. So this point here, when I draw a vertical line to that position there, this position on the x-axis is not the farthest left that it's going to go. It can eventually reach to -2 because the arrow is still moving downwards and to the left. And because of the arrow, it could eventually reach to -3 and then -4, -5, -6, and so on and so on. So in this situation, there is no lower boundary. So the domain for this, I'm going to start by first writing in set builder notation and inequalities, using inequalities. The lowest value I can reach is technically -infinity because this thing is going to continue moving to the left downwards. All right, it's continue moving down, but still to the left. So in terms of x's, there is no lower boundary. Now, what's the farthest to the right that the graph can reach? Well, if I again start somewhere on the graph and move to the right, I start by moving up, and then I start moving downwards, but I'm still moving to the right until I reach this point right there. So that point is the farthest right that the graph is going to go. So all my x values are going to be to the left of this, but since there is no lower boundary, there's no point that's going to be to the right, because every time I find a lower boundary, the arrow indicates that it's going to continue moving to the left. So there will be another lower boundary, and then another lower boundary, and another lower boundary. So I never stop finding lower boundaries. And again, that's why we have -infinity. But on the right side, not to worry, we found a lower boundary. Found an upper boundary, and that upper boundary is 3. So our domain here will be all the x values between -infinity to +3. And because there's a closed circle on this endpoint, we're going to include 3. So we're going to indicate that by putting an equal sign underneath that inequality. Now let's translate this into an interval. So as an interval, our lower boundary is -infinity. Before I go into interval, on your homework assignment, this will not be marked correct if you write your interval like using inequalities like this. Because the left end has no lower boundary, it's expected for you to only write the end that does have a boundary. So in this situation, that boundary would be here, that x is less than 3. So ignore this part. I'm going to scratch this out. And we're only going to write this part right here that I'm boxing in red, that I've highlighted in yellow. Now let's translate this into interval notation. So in interval notation, we do have to have a lower and upper boundary. So we do have to write -infinity and 3. We're going to have a parentheses on -infinity because we do not include that endpoint. And since we do include the endpoint of 3, we're going to use a bracket there. So this would be the domain in interval notation. Let's now identify the range. So using set builder notation and inequalities, I recommend that we start by writing our inequality where y is in the middle, and we have our less than symbols on the left and on the right of that y value. So we need the lower boundary on the left and the upper boundary on the right. We're looking at the graph. There is no lower boundary. Because of the arrow, we're not going to stop at -5. The arrow indicates that it's going to continue down, so there will eventually be a point that we can connect to the y-axis at -5, and then -6 and -7 and so on. So there is no lower boundary, so eventually we'll go as low as -infinity. Now there is an upper boundary, and it's not any of this endpoint right there at -2. Notice that there's a point right here, or this point right there, that's higher, -1 and 0. There's even a point higher than that, 1, and a point even higher than that. So this point right there, that point right here is the highest, which reaches again at 2. Or reaches at 2, not again at 2, but reaches at 2. So this point here is the highest, and all my y values can be found underneath this red line. Every single point that's on this graph is going to have a y value that is not higher than the number 2, only equal to it. So our upper boundary is 2, and since we're going to include it, we put an equal sign to indicate that. And as an interval notation, -infinity to +2 with an open parentheses and a bracket. Now, let me go back to the interval notation, okay? I'm sorry, the inequality one, the one I have right here in red. Just like the previous example, I cannot include this portion right here of the inequality because there is no upper boundary. If you type in all of this, it's going to be marked incorrect on on either one of the two questions where you have to write it as an inequality. The expectation is to only write to this end right here and to say that y is less than or equal to 2. If the inequality was backwards, and let's say we had a graph, let me do a different color, and let's say that we had a graph for domain or range, okay? Let's say x less than and less than, and we had 5 and infinity on this end right there. Again, we would not include this end in the solution box. We would only include this portion here. So our solution would be that x is greater than 5 or 5 is less than x. So you could just simply set up like the way we did the previous one and just ignore the side that has the infinity, which in this case would be the upper boundary. And if you just type that, that will mark it correct. And now our final example, we'll begin yet again with the domain. And again, the strategy is the same. So we're simply going to trace on the graph, so anywhere on the graph, and try to move to the far left. So moving upwards takes us to the left. It moves it to the left until we get to this endpoint there. Notice that there's no graph to the left of this vertical line right here, which is at the x value. It intersects the x value at 1. So -1 is the lowest value that this function is going to reach along the x-axis. Now, what's the farthest right? So if I just start anywhere in the graph and try to move to the right, which is also moving me down, the farthest right I reach is this point right there, which intersects the x-axis at +2. So as an interval, my domain would be the x values between -1 and +2. Now, because of closed circles on both ends, I would simply put parentheses under each inequality, and as an interval, I simply put brackets. Now, what about the range? Well, for a range, simply start at the bottom, see what's the lowest y value we can get to, which is again this endpoint right there. There's no point lower than that. So -4 is the lowest y value. And the highest y value moving upwards and to the left will eventually get to this point right there, which is at the y value of 5. This is 4, so that's 5. So the y values are going to be between -4 and +5. So that's our range. And because again, they're both closed circles on those two endpoints, we're going to put in equal signs to indicate that, which as an interval notation simply uses brackets. So there you have it. Again, the technique and strategy to finding the domain and range of a relation using a graph. Now, again, just a last minute reminder, when you're working on the homework, read the question carefully. 2 questions require you to write in your answer as inequalities as these examples I have right here, and all the remaining 8 require you to use interval notation. So make sure that you're writing in your answer in the proper format, because if not, because even though you might have the right interval, it's going to mark it wrong because you're supposed to write it like this instead of that. Okay, well, that's it for this section. I appreciate you watching, and I hope you have a great day. Goodbye.